Okay, so equation of a line tangent to a rational function. So this question here, this is your second example in your book there. They've given us determine the equation of the tangent to this function y is equal to 2x divided by x squared plus 1. And they want it at the point where x is equal to 0. Okay, so in order to find the line tangent to this, we're going to have to derive this function. And because it's a function divided by another, we're going to use our quotient rule. We also need to find out what point x will be so that we know or we'll be able to find the equation of the line. But we'll do that part last. First step we'll do is we'll derive this function. So in order to derive this function, we're looking for y prime. Remember, instead of f at x, we're using y in this case. And we're just going to denote these so we know that this is our f at x and this is our g at x. So for our rules, when using quotient, we need to find f prime x. So f prime is 2x. When we derive that, we're going to get just 2. And it's going to be multiplied by g at x, which is the original function on the bottom, x squared plus 1. We then subtract by the original function on the top, f at x, which is 2x. And it's going to be multiplied by g prime x. So the derivative of the function on the bottom, which is technically 2x. Okay. And all of this is divided by the original function on the bottom squared. So our original function on the bottom was x squared plus 1. It now becomes squared. Okay, so this is our gx squared. So we got that part. Technically, I have my y prime. Okay, so instead of actually working out all of our distributive properties and simplifying, they want us to solve it when x is equal to 0. I could do that. I can simplify. Or I can just decide to plug in x at 0. I know you can't quite see it. X at 0 at this point in the question. So we still know this is y prime. This time we're going to replace x with 0. So we're left with 2 multiplied by 0 squared plus 1. Subtract 2 by 0. 2 times 0. All divided by 0 squared plus 1 squared. So let's figure out what that's going to be. What's 0 squared? 0. Plus 1? 1. So 1 times 2 is 2. So I actually have a number for the first set of terms. 0 times 2 times 0 times 2 is still 0. And on the bottom, we're left with 0 squared, which is 0, plus 1, which is 1 squared. So we're left with 1. So in the end, we end up with the number 2. So we know the slope of the tangent at x equals 0. The slope, or m, is 2. So if we're putting in y equals mx plus b, we have our x, we have our m. We don't have a y because we don't know what the point is. So we actually have to go to the original function. Okay, and we need to plug in 0 into the original function. Now our original function was y is equal to 2x over x squared plus 5. I need to plug 0 in to find out my y value. So I'm going to get 2 times 0. I don't really, unless it becomes 0 at the bottom, which it will not. 0 squared plus 5. 0 divided by anything will be 0. So, oh, not plus 5. Sorry, plus 1. In this case, won't make a difference, but thank you. Make sure it's the right question. We're still going to end up with 0 on top. So our coordinate is going to be at 0 and 0. So x and y. So when we go to plug this into our slope y-intercept form, our y value is 0. Our slope we discovered to be 2. But our x value is 0. Not equal, but plus b. We're trying to solve what our b is going to be. Well, b in this case is going to be 0. Okay? And our y value is 0. And our x value is 0. So what we're going to find here is our slope is going to be y is equal to the slope, which is 2. And there's plus 0. We don't really need to write that in. So the slope of the line tangent to this point is y equals 2x. That's it.